Hi students, welcome to digital classes. Today we are going to discuss about 10th class mathematics polynomials first part. Okay children, you might have seen different graphs and everything in previous chapters polynomials. Today let us check learning outcomes. By the end of this lesson, students are able to define the polynomials and can find the degree of polynomials, substitute and get the value of polynomials, understand the zeros of polynomials. After understanding, we can draw the graphs. Geometrically, what are the zeros of polynomials, and we can draw linear polynomials and quadratic polynomials also. By the end of chapter, we will discuss all these topics. Okay children, let us come to the polynomials. Before going to start, there are three sides in a triangle. First side is half of the second side and the third side is 3 times the first side. Can you guess the measurements of triangle? See, without giving extra information, we may not get the sides of triangle. So, we will take one unknown value. Suppose here the triangle is like this. First side I have taken here x centimeters, then it is half of the second side. Then the second side will be 2x centimeters and third side is 3 times the first side, hence it becomes 3x centimeters. These three sides depends on one unknown value x. Can you find the perimeter of this triangle? What will be the perimeter of the triangle? Yeah, the sum of the sides is the perimeter of the triangle. Now, by adding these three, x plus 2x plus 3x, we get the value 6x centimeters. The perimeter depends on the value x here. So, here this is the combination of 6, one constant, and x, one variable. So, this is the combination of constants and variables. Let us see one more example here. Now, I have taken one rectangle whose sides are 6y centimeters and 5y centimeters. Can you find the area of this rectangular field? Now, the area of the rectangular field is length into breadth. Now, the area becomes 5y into 6y gives us 30y square. Here also we have the combination of constants and variables. These are the expressions which contains constants and variables are the polynomials, and we have some particular condition to define a polynomial. Already you might have studied in previous classes. Let us go into some more examples to define the polynomials. I am giving you some examples. 3x square, 6t, x square plus 6x minus 9, and here it is under root of 3x cube. See the students, all these are the examples of expressions. From among all these, try to say which are polynomials. What is the condition to define it is a polynomial? See here minus 4z, 2m plus 7, 2 by x square. So, here the variable has different exponents. So, first one, this is a polynomial, but whereas root 3x cube and 2 by x square are not polynomials. Why? Because the exponent of the variable, that is, should be positive integer. Observe these exponents. So, exponent of variable should be positive integer. So, polynomial should contain combination of constants and variables, and the exponent of the variable should be whole number or positive integer. Now, let us define, and it should contain finite number of terms. So, here some polynomials have 2 terms and one polynomial has 3 terms. So, let us define clearly polynomial definition here. See students, a polynomial is an expression which consists of variables and constants. So more particularly, we define the polynomial as like this. Here a polynomial is in X is an expression containing the sum of finite number of terms of the form a x to the power of n. Here in this, a is a coefficient. We can take any real number in the place of a, and n should be whole number. It should be not negative and it should be not a fraction. So this is the definition of polynomial. I will check your learning ability now. How many have you understood? You check yourself now. So here try to say which is a polynomial and which is not a polynomial by observing the exponent of the variable. Okay, 2x cube. Is this a polynomial or not? What is the exponent here? What is the variable here? And try to read this. First of all, try to read this. 1 by x minus 1. Here the x appear at denominator. How to write the exponent of x here? See this. Here it can be written as x to the power minus 1 minus 1. Now what is the exponent here? Is this a polynomial? Okay. Next, see this 4z square plus 1 by 7. Every student should be able to read the expression first. So try to read clearly the variables and the syntax. 4z square plus 1 by 7. Try to read this one. M square minus root 2m plus 2. Coefficients can be any real number, but the variable exponent of the variable should be whole number. So try to write which are polynomials and which are not a polynomial. Here fifth one, p to the power of minus 2 plus 1. Is this a polynomial? Obviously it is not a polynomial, since the p variable has the exponent minus 2. As it is negative, it is not a polynomial. So hence you might have understood what are polynomials. Now let us go to particularly the exponents of the variables and which is the highest exponent. Teach us the degree of polynomial. Let us come to the next one, degree of polynomial. 3x to the power of 3 plus 4x square minus 5x plus 1. What is the highest exponent in this polynomial? What is the variable in this polynomial? Now see this. I think this is the highest variable. Exactly. Now we can define the degree of polynomial. The highest power of the variable in a polynomial is known as degree of a polynomial. So here what is the degree of the above polynomial? 3. Children, try to tell me what is the degree of this polynomial. Read the polynomial once. Try to note every polynomial, every example which is appearing on the screen and answer my questions. X to the power of 3 minus 4x to the power of 5 minus 5x to the power of 6 plus x. It is not given in descending order of exponents. So try to read every term. Now what is the highest exponent of the polynomial? Exactly. So here what is the degree? Yes, this is 6th degree polynomial. Now try to tell me what is the degree of this polynomial and what is the variable here. Please children, everyone try to read this polynomial clearly and properly. Okay. So mathematical language is very important. We have so many syntaxes, so many symbols. So everywhere we should be cautious to read a particular expression. Now you are ready with this degree. So what is the degree here? Exactly. So all of you told very right. The degree of this polynomial is 10. Okay. Let us go to the next one. Here, types of polynomials based on degree. We have observed here lot of examples, various variables. Now with the help of the degree, we will have some names particularly for polynomials. Now try to read these polynomials. 6t, 3x, 2m plus 7. These all polynomials have degree 1. The polynomial whose degree is 1 is called linear polynomial. So why it is linear polynomial? The name indicates that when you draw graph of this polynomial, it represents one straight line. So it is linear polynomial. Now try to read this and tell me the degree. Okay, this is second degree polynomial. Okay, I am not going to read, you read yourself. And what is the name of this polynomial? Yeah, exactly, quadratic polynomial. The degree of 2, the degree of polynomial, if the degree of polynomial is 2, then it is quadratic polynomial. Now we have one more example here, which is third degree polynomial. Now it is called cubic polynomial. Names of different polynomials. From now onwards, if it is fourth degree, so there is no particular name, just simply fourth degree polynomial. So here one example is given, 4p cube minus 2p to the power of 4 minus 5p plus 1. Here the exponent, highest exponent of variable is not at first place here. So we should read all the terms, then should decide the degree of the polynomial. Now see this polynomial. What is the degree of this polynomial? Where is the highest exponent to this letter R? Yeah, it is fifth degree polynomial. Obviously the name of the polynomial is fifth degree. Can you write an example of more highest exponents? Next higher level, sixth degree, seventh degree, like that. Now try to give an example of sixth degree polynomial in x. So one example I am showing you on screen, 6x to the power of 6 minus 7x cube minus 8x to the power of 4 plus 9. This is one example. Try to write more examples in sixth degree polynomial. Children, try to write ninth degree polynomial in x. Before I show one example, you try to write examples of ninth degree. You can write one term, you can write two terms, like that. At most you can write 10 terms in any polynomial. Here see the example which I have shown on the screen. Minus x to the power of 6 minus 4x to the power of 9 plus 5x square minus 2. Here I have taken only 4 terms. All the terms and every exponent, no need to write in any example. So try to write like the different exponents and different degree of polynomials, like that 7th degree polynomial, 10th degree polynomial and 50th degree, like that. Can you write general polynomial of nth degree by taking different variables? Okay, take any variable and write any number of terms for 20th degree polynomial or 50th degree polynomial. Like that, try to write more examples. More practice will give us more perfection. Now I am going to write this nth degree polynomial. Try to understand and try to read. So here I have taken the coefficients as a0, a1, a2 up to an minus 1 and an. a0 or a0 x to the power of n plus a1 x to the power of n minus 1. All possible terms, if we write this is the general polynomial of x. Okay, here a0, a1, a2 are any real coefficients. We can take any real number. With the help of this, we can write any polynomial. So try to tell me how many terms can we write in 12th degree polynomial. How many maximum number of terms we can write. Okay, this is general polynomial. Here n should be natural number. We have started from x to the power of n to and last constant term. Okay, you try to change the variable. Here I have taken x. You try to change the variable t. giving you one open-ended task. Write general polynomial same like above in variable t of nth degree, and here try to take the constants or the coefficients m0, m1, m2 like that. Let us come to the general forms. What is the general form of quadratic polynomial? Let us check now. Instead of writing a0, a1, a2 up to an, let us write maximum number of terms in general form. Here I have taken on tabular form. Now degree and general forms, just have a glance. First one, linear polynomial. So ax plus b, where a and b are any real numbers. Here a should not equal to 0. Now go to second degree, that is quadratic polynomial, and try to write the general form. So any type of coefficients we can take here. Here I have taken ax square plus bx plus c. This is general polynomial of quadratic, second degree polynomial, general form of quadratic polynomial, and try to write cubic, general form of cubic polynomial, ax cube plus bx square plus cx plus d. How many number of terms it has? 4. And in general form of quadratic, how many terms are there? 3 terms are there. If you want to write fourth degree general form, how many number of terms we can write maximum? Okay, yes, 5. So just have a look here. Ax to the power of 4. Here first term where we are writing a, it should not be equal to 0. Ax to the power of 4 plus bx cube plus cx square plus dx plus e. Now, so this is general form of fifth degree polynomial. From this tabular form, you can write any polynomial general form here and any example also. So in the place of coefficients, we can take any real number, but exponent should be whole number only. Then only it is polynomial. Otherwise, just it is algebraic expression. So now let us try to find value of a polynomial. How to find a value to a polynomial at particular variable, particular constant. So now let us consider one polynomial. P of x is equal to x square minus 6x plus 9. How to find the value of this polynomial at various values of the variable x? What is the value? Okay, what is the value of this polynomial at particularly x is equal to 1? If you take x is equal to 1, what will be the value? For this, we have to substitute x is equal to 1 in this polynomial. Replace x with 1. Polynomial becomes like this. P of 1 equal to 1 square. In the place of x square, 1 square minus 6x, 6 into 1 plus 9. Simplify this and try to write the answer. 1 square becomes 1, 6 into 1 6 and plus 9, and add and subtraction. What will be the value? Yeah, it is 4. Try to write the value of this polynomial at x is equal to 2. To find the value of polynomial, we should substitute the value 2 here in the place of x. Replace x with 2 now. So it is 2 square minus 6 into minus 2 plus 9. So value of this polynomial at x is equal to minus 2. Hence the value is 25. P of minus 2 is equal to 25. Okay. Particularly these things. So now I will give you a small task. Try to write in your notebook and try to solve. Find the value of this polynomial at p of 1, p of minus 1, p of 2 and p of minus 2, p of 0. Okay. And one more example here. Find the values of p of 1 by 2, p of minus 3 by 5, p of minus 1.5 and p of 0.02 and p of 0 in p of n equal to 2n square minus 3n plus 1. Okay. Let us try to discuss about zeros of a polynomial. Okay. Now, let us consider one polynomial p of x is equal to x square plus x minus 2. As we learnt earlier, how did we find the value of a polynomial? Now, substitute x is equal to 1. What will be the answer here? Yeah, this is 0. Now, try to substitute x is equal to 2 here. X is equal to minus 2. Then what will be the answer here? Minus 2 whole square plus of minus 2 minus 2. Hence, the answer becomes 0. Try to substitute any another value instead of x here. Replace x with t, then we will get the answer here 10. But in first two cases, when we substituted here x is equal to 1 and x is equal to minus 2, those are zeros of the polynomials, because we obtained the value 0 here. Okay, students, you might have understood here. So, by substituting any value, if we get 0, the final result, then the particular value is called 0 of the polynomial. Okay. Now, we have to see how the polynomials will have in their geometrical representation. Let us have one linear polynomial, that is p of x is equal to 5x plus 6 here. Okay. Now, what if k is a 0 of this p of x is equal to 5x plus 6, then p of k is equal to 0. Hence, here substituting k in the place of x, we get 5k plus 6 equal to 0 by transposing the constant to right side. Hence, 5k is equal to minus 6, and the next step k equal to minus 6 by 5. Now, this minus 6 by 5 is the 0 of this polynomial. In general, if k is 0 of p of x is equal to ax plus b, where a not equal to 0, then ak is plus b equal to 0. Then by transposing, we will get k is equal to minus b by a. In general, 0 of any linear polynomial in the form ax plus b, then 0 is minus b by a. This is the general form of linear polynomial and it's 0. Let us look the geometrical meaning of the zeros of a polynomial. Now, we have observed if p of k is equal to 0, then the geometrically, when we draw the graph of that particular polynomial, it intersects the x-axis at the value k comma 0. If p of k is equal to 0, then in the graph it intersects the particular curve or line, it intersects the x-axis at that point. So, here this is example of one general example of a polynomial which intersects the x-axis at k comma 0. The x coordinate of the intersecting point of x-axis and the curve is the 0 of the polynomial. Okay. We shall now take one example to draw graph of it, linear polynomial and quadratic polynomial, and try to find 0 of the polynomial graphically and as well as algebraically. Okay. So, let us consider one linear polynomial, that is p of x is equal to 2x plus 6. To draw any polynomial, we should assume that y is equal to 2x plus 6. If we have both coordinates x and y only, we can plot the points in the graph and as well as we can obtain the curve of the polynomial. Now, to obtain the ordered pairs of this polynomial, let us tabulate the ordered pairs by taking x value and as well as y value. Here in this, you take any value instead of x and substitute it in the 2x plus 6 polynomial. Then we will get the y value. Suppose x is equal to 1. What will be the polynomial now? Already we found so many times value of polynomial. Now it will be 2 into 1 plus 6. Then y is equal to 8 here. Like that, try to find when x is equal to 2. Okay. Have you found it? Yeah. Now check with your answer. If you already have finished, now check with this answer. 2 into 2 plus 6, that equal to 10 here. Now try to write one negative value instead of x. X is equal to minus 1. Finish the answer. Okay children, now see the answer. 2 into minus 1 plus 6, that is 4 here. Now try to write the ordered pairs from this tabular form. X comma y, first value is 1 comma 8. Like that, there are 3 values here, 1 comma 8, 2 comma 10 and minus 1 comma 4. Now let us take one graph paper. By plotting these 3 points, we will get one graphical representation of this particular 2x plus 6. Now I am taking one graph paper here. All of you observe this graph paper. Here one vertical line and one horizontal line. Horizontal line which is called x-axis and vertical line which is called y-axis. Now see the numbers on those two axes, how we have taken here, that is called scale here. Now the scale factor is, on x-axis we have divided each centimeter into 1 unit. In the same manner, on y-axis each centimeter we have divided into 1 unit. As per our requirement, we need to take the scale factor here. We should observe the x coordinates and we should observe the y coordinates. So here we have 1 comma 8, 2 comma 10 and minus 1 comma 4 here. Now try to plot the points. First one, 1 comma 8. We should consider 1 on x-axis, 8 on y-axis. The intersecting of this is 1 comma 8. Now observe this point where it is located. So there it is. Okay, like that. Plot the second point, 2 comma 10. Now where it is located here, 2 should be considered on x-axis and 10 should be considered on y-axis, that is 2 comma 10. Okay. Now try to plot the third point, minus 1 comma 4. Minus 1 negative side of x-axis and 4 should be on y-axis. The intersecting of these two is minus 1 comma 4. Now that is minus 1 comma 4. Now try to join these 3 points with ruler. You will get one straight line like this. Okay, see this straight line, like this we will get one straight line. Observe that straight line where it is intersecting x-axis. Where it is intersecting x-axis, here observe the point, it is there at minus 3 on x-axis. So write the ordered pairs here, minus 3 comma 0. Hence here algebraically also you try to find 0 of this linear polynomial. From this graph we obtained minus 3 as 0. Let us check. 2x plus 6 is equal to 0. Try to transpose it. Send the 6 towards right side. By transposing, it will be 2x is equal to minus 6. And now x is equal to minus 6 by 2 is equal to minus 3. Okay children, see the 0 of the polynomial by algebraically. Now minus 3 is the 0 of the polynomial. Okay. Now let us have a glance, one more example, same like this. Try to draw the same graph in your graph paper. Okay children, see the polynomial p of x is equal to 4x minus 1. Let us assume it as y is equal to 4x minus 1. Now tabulate the values, ordered pairs. So here by taking 1 we get 3, by taking 2 we get 5, 7, by taking 0 we got here minus 1. Now the ordered pairs are 1 comma 3, 2 comma 7 and 0 comma minus 1. So by plotting these 3 points in graph, 1 comma 3 where it is there, 2 comma 7 there it is, and 0 comma minus 1. Hence by connecting these 3 with ruler, we will get one straight line. Observe the 0 of the linear polynomial graphically, where it is. So here it is 1 by 4 comma 0. Algebraically also check once. 1 by 4 is the 0 of the polynomial. By this, you try to draw different linear polynomials in your graph paper and obtain 0 graphically and check it with algebraically. Okay. Generally, if we take ax plus b, we will get the 0 as minus b by a. So minus b by a is the 0 of the general polynomial ax plus b. Okay students, solve exercise problems in your chapter Polynomials, 3rd chapter, and try to solve all. Okay. Thank you one and all.